Welcome everybody to the BCS West Yorkshire's branches talk on the fundamental concepts in responsible artificial intelligence for real-world applications. I would like to welcome back Professor Daniel Neagu, who has given a talk in the past for us and proven quite popular. So we are going to ask any questions. I will be keeping an eye on the chat. And any questions for the end of the presentation, please. But as said, I will be keeping an eye on the chat as well, and we'll be able to respond to some potentially. On that note, I would like very much to hand over to Professor Daniel Neagu, and thank you for your time.
Thank you. Good afternoon, everybody. Chris, Dan, thank you very much for the invitation. I truly enjoy this time because I'm trying actually to introduce everybody through some concepts, ideas, challenges, and dilemmas that I was facing as a computer scientist who started understanding that we are more than, say, workers and or scientists, and started actually claiming our humanity during very interesting times. So this talk today is simply addressing my own questions and my own ways to answer based on, thankfully, the philosophical discussions I started having with my wife, Justina, who's studying philosophy. So what you see in this afternoon, which I know is a Friday afternoon, and people could think that could do better things, but believe me, this time you'll enjoy it because we'll add a personal note to something that is fashionable nowadays, and this is the artificial intelligence, when actually I like to demonstrate that actually the humans and our approaches are in the core of what we see, and this adds good news for everybody. So this is why actually the keywords in here are all challenging. I cannot say that I'll be very balanced in terms of my presentation. It could be very long or very short. And I'm not sure if I'll address everything with the same equitable proportion, but definitely actually I am happy to share with you what is going on and to share with you in a way that we can build together because that's the word, to build together the future. So it's a Friday afternoon. It's a Friday in which we enjoy in Yorkshire sun and good weather. And that shows that we as human beings are actually interested to communicate with the environment and with the other members of our society. Say it in general terms, anybody we like to share information through input output abilities that we have through our sensors. And this is actually a keyword that I'll come back to it. But we know that we live in a society and automatically we have to obey rules, sometimes actually to think about the new rules and to try to understand our place within the society and the nature. And this is the point of the review because I want to identify with you and to share with you the fundamental concepts, the keywords, the meaning of those keywords that for different people may have different facets of the truth, and to understand how we can build on them within the challenging and opportunities times of artificial intelligence. And I'm trying to get into this discussion the principles of sustainable and responsible artificial intelligence, but we need to put them on the map. And this map is very dynamically changing shape and at the same time, say, context. So let's try to identify how we can make our presence visible because tomorrow will be knowledgeable within the domain of artificial intelligence from a sustainable and responsible perspective. So let's try to discuss about the concept. I just acknowledge in all my slides, the in my presentation, the sources. They were involving much work, and actually they are better witnessing industrial revolutions at the and again, thankfully, as I mentioned already last year, Bradford and Yorkshire were part of some of these industrial revolutions. Industry 1.0, in which the power generated by steam and water were making the mills producing industrially wool textiles. But later on, and weaving, of course, the textiles for lower price, better quality of the materials for people to use. And then Industry 2.0 came with the electrical power. But remember, so the first keywords, power, the second again is power, it's just the type is different, the price will be different. Industry 3.0, in which we started seeing robotics, actually the times that were creating, say, the context for my studies at the time in computer engineering in 1980s, and Industry 4.0, in which actually we started seeing the smart keywords jumping in, where in the past were just power and production. And nowadays, Industry 5.0, where the Industry 5.0 has been already introduced by the European Commission and at the same time actually by other governments, like a way to refocus on human and having people centricity, where in the past were just mechanical and energy focus into, say, production. We'll see that actually there is here a trigger, a trap, and an opportunity as well. So look at the dates. Bradford was in 1784. The Liverpool Canal that was coming through Bradford as well is dated into the 1775-ish time. So you can see Industry 1.0 in there. We know what Industry 2.0 was doing, and we remember the robotic stories for Industry 3.0. But machine learning and smart factories, as well as actually the cyber physical systems with cognitive functions, started happening during our times. I'm kind of sad actually to remember that actually I was part of some of these revolutions, but look at Industry 6.0, which is a keyword that if you search a little bit the internet, you'll see that actually is claimed by many people with many approaches. What I want to add in here is the keywords. So Industry 1.0 is actually mechanization. So it's the mechanical revolution. Mechanics means actually the power of humans, of horses, but donkeys even actually moving, wheels and so on, moved into the steam power that was freeing our hands. Industry 2.0 is the electrical revolution. The power becomes cheaper, and thanks to electricity, it started to be distributed and making our lives easier. Automation in Industry 3.0 had a stepping stone, the globalized revolution. So automation first, reducing the price of manufacturing, and then actually the distribution globally of the same revolution in the 80s made having everybody actually the chance to start enjoying education, hopes for a better life, healthcare, social care as well. So the effects were there, but the costs were coming as well. Industry 5.0 is what everybody's still talking nowadays, though, as you can remember, it started, let's say, in the early 2000s with the goods and the bads as well. But this is related to some keywords we're still playing with: blockchain, Internet of Things, cyber physical systems, robotics. But what is the challenge and the change in this time is the move from water power, steam power, fuel power, electrical power to data power. So we're moving into a data centered revolution. Is data now started actually to have memory available for us? We started actually storing data, and then we're asking, okay, how can I make an industry from the data? And this is where cyber physical systems started, in particularly manufacturing sector originally, of course, and then moving in so many sectors. We remember the healthcare revolution, the sensors coming in, and the keywords of smart city, cars, planes, smart offices, and so on were actually making their way in everybody's life. But at that time, there was no human being in there, but just like a user, a client, a designer, a producer, a worker. So, where is the human? We were asked, and this is where Industry 5.0 starting practically climbing at the same time with Industry 4.0. So they are a little bit intertwined. So the human-centered revolution is claiming the participation of the human centricity, so human at least in the loop, as they are saying, because actually the cyber physical systems need still the power of the human intelligence. And this is done with the multimodal user experience, the interfaces, playing actually with so many systems that we are now very accommodated with. But a question mark started appearing, because this is the moment in Industry 5.0 when we're seeing the data processed at huge scale, the robots claiming territory into the human behavior. And we start thinking, oh, right, so are we going into the humanized revolution of the mechanics and the cybers? What is going on in this area? Look on the right side of the screen, and we'll see that actually I'm attaching some philosophical words. The green side of power, put it this way, are mostly related to the Cartesian approaches, Descartes, like a philosopher approaches of the dualism body and mind. Body was separated from the mind, and the body necessities are all these revolutions we're talking about. But from Kant, from the Kantian philosophy, we started thinking that actually cognition, knowledge, are starting claiming territory, and this is where the human is needed back into the body. So the body and mind start to be together. There are two coins, two sides of the same coin, and the cognition is making sense to come in together. But what is the future? When the mechanical body started actually having a mind, what is going on? And this is the same motivation for my talk today. We are aware of, say, the pyramid of needs. We are fully aware of the basic needs that we need to satisfy in order to accumulate time, time for education, for intelligence, to start thinking. Well, but actually, this is what um, many researchers were trying to introduce in terms of the what is called DIKW hierarchy or pyramid as well, which is another way to express within our this time science and technology domains the pyramid of needs. The basic of the pyramid of needs, the base part of it, is the raw data. And indeed, we build on it on the information. We'll see in the next slide actually why data and information, although they kind of start being amalgamated, coming together, they need to be acknowledged separately because of the technology. Look on the green side of the pyramid when we're talking about the technology equivalence, whereas on the right hand side of the pyramid we're talking about the human equivalence. And this kind of a dual approach, this kind of a presence of technology and humans within this is what I mentioned as the journey of our industrial revolutions. So where is the next step within this kind of a journey towards the top of the pyramid? Well, is the knowledge in the first attempt, and hopefully on top is the wisdom. But wisdom, is this a word that we see it in technology? Just let's try to reflect a little bit. Have you seen wisdom in anything related to nowadays talks? No, we see data. Do you? Yeah, I'm sure actually you are not in now saying data. It's impossible not to see data. I'll refer back in a second about the fact that data in itself, while actually now we see it as a noun with whatever format, it has the Latin roots that will justify its presence at the base of the pyramid, which is datum. And datum is given, is the raw given, is actually the raw materials of knowledge, put it this way. Raw means that are close to the say low level, which is hardware from the technology perspective. So data is close to the heart of the digital technology, of the computational technology. And this is why the datum is there. Whereas information is mostly related to our human senses. Is multimodal. We react to the fact that we are able to see, to hear, to taste, to touch. So all these senses that we have are making the information different to some extent to data. But nowadays, the computational technologies, the computing technologies, the hardware are making this, say, border between data and information far more vague, and they started actually to play an interchangeable role. And this is why people may be confused in terms of, oh, yeah, you want my data or you want my information, are both actually shared by everybody. But knowledge is important. And knowledge is important from many perspectives, including technology, science, and more. So, where is the intelligence in this pyramid? Where actually intelligence is the ability in a multimodal world, because of our human body and mind integration, is the ability to learn. But learning involves a number of steps, from acquiring the data information, understanding it, processing it, hopefully memorizing it to some extent, so retaining somehow, and then applying it in order to, so learning from experience to solve problems, reason, adapt ourselves, and engage in wisdom generation, in say abstract thinking, in which we are making use of our input output, so our senses, in order to communicate to the world. So you can see that intelligence, and I'm talking here from a human perspective, encompasses all these kind of mental abilities and skills that put ourselves into the body mind dual approach of our existence. Okay, so where is the technology here? Actually, technology is there because the input output systems now are playing the game of the sensors, our senses. The memory is playing a very cheap price, actually, to some extent. Of course, depends how we measure sustainably or not. This is the playing the retaining game, and the functional brain, the computational power, are doing the role of processing, with the question mark on understanding. Let's move on and see more about this. Well, actually, what I can say, thanks to the pyramid of DAKW, which has been practically produced by Fricke since 2000 and say Industry 4.0 revolution times, intelligence is defined as the ability to think logically, and to abstract from reality in order to solve problems with ability to generalize, to reapply the solutions we design. But logics, well, logic in itself is a philosophical word. Logic comes, at least from the Western side of the story, from the Greek times, the Greek philosophers that were the inventors of the Western philosophy, that were, of course, continued during the Roman times, during the medieval times, and so on. Don't forget that actually it's not just the Western philosophy here. This is where actually I'm mentioning the logic, because the Western philosophical logic is not a single way to progress, but is the way that has been captured in the current solutions for intelligence by technology side. So thinking logically, so logic is a part of the philosophy. Do you know what is the other main keyword that started, has been introduced by the Greek philosophers and was continuously discussed by the other philosophers, including nowadays? Now, I do not see you, but I'll say the word and you check it out. I stop my interaction, so practically you to vote because I have so much to share with you. But the other word is ethics. So we have intelligence by logic, which is embedded in computers, in the hardware. But where is the ethics there? And is the ethics related to wisdom? How the wisdom is defined then? Well, your wisdom is defined as the ability to grasp human nature. That is, to my extent, actually, I know I'm in there. I'm trying actually to challenge you to find out if we are altogether paradoxical, contradictory at times. Let's hope not too much. But sometimes contradiction means creation as well, creativity. And indeed, we're subject to continual changing. We are learning from our mistakes and successes and produce more. Lovely. So if that is the case, let me focus on both sides of this slide. The left-hand side, in which Data, I mentioned, is the raw input, is the food, the fuel of the production of information, knowledge, wisdom, and it comes with the know that part, which is the philosophical approach, the know that is called by us information. Whereas knowledge in itself, this kind of a way to reflect, to practically process and understand the data and information, so what we receive through our sensors, is actually the know-how. We can say that actually we're already doing it, isn't it? We know we search for the information and then we try to create the know-how, as creativity is part of our daily existence. Okay, so information is moving into the knowledge from the, say, weak knowledge, knowledge that, know that, into know how. But look at the bottom of the pyramid in there. I entered the challenges. Where we are, where are the gaps into our current creativity, and how the industrialization, the generalization, globalization of, say, data and information as an industrial revolution is stopping us. So we are one step ahead as humans, because if you look onto the right hand side, we have data. For data, we have data science, and we have data engineering. Is a word that works, and we know how we engineer data, as well as how we look at the data from a scientific perspective. Our people actually with the library interest and librarian, and not just and management approaches, they are aware about the information science. And we have, of course, information engineering with metadata, with design of the database and so on, part of our game in there. Very good. And then actually we moved into knowledge engineering since 1980s. I've done my own part of that training as well. But where is the knowledge science? Anybody? Yes, it's called epistemology. We are stepping back into the philosophical approaches. Epistemology, the way actually to process knowledge. And thanks to the Kantian philosophers, actually, and not just, we know that reasoning is part of the definition of knowledge. But where is the wisdom? Where is the wisdom? Well, from the scientific perspective, this is done from early stages of the humans who save their brains by actually putting mechanical power, electrical power, and so on, and robots in there. So we're starting being philosopher and practically thinking, producing wisdom. But where is the engineering of the wisdom? Well, is a challenge. If you find the word, send it to me, please, because I was not able to find a wisdom engineering story. Still a question mark in there. And indeed, at the moment, we can see the game of weak knowledge and strong knowledge making their ways into our, say, life, because the weak knowledge, the knowledge that the expert systems, the say data-centric approaches were happening since 1970s, 80s, and nowadays through the Industry 3.0, 4.0 revolutions and more. But we are facing a challenge from artificial intelligence producers, and we don't know how to manage it. And we should ask at least the philosophy to help us, the engineers and the scientists, to put it in there and to help us to produce the know-how, the knowledge, and wisdom engineering side. Because still, the knowledge at that level, at the top level, is not manageable easy, isn't it? This is where the challenge of the artificial intelligence is making our lives, say, booming of interest, but at the same time of um, we don't know the future. We don't know what is going on, isn't it? So, looking from this perspective and looking at the journey now, because I practically redefined data as the raw information, put it this way, information as the source of the knowledge by processing and understanding it. So, becoming actually the know what towards a know-how, solving the problems, introducing creativity as a technology, we can see actually that what we're doing, we're trying to free our minds even more, to have time to create, to become, say, what? Do you remember what I said? I said we have the side of logic and its implementation, but we're missing the humanistic side, which is technically the ethics. Just to remind you back about epistemology, the knowledge of science, That's the philosophical study of the nature, origin, and limits of human knowledge. But nowadays, as we can claim what is knowledge in there, and indeed to understand that the reason, the knowledge of reasoning, and the way to produce practically new knowledge is the journey towards wisdom. Is a journey. I can definitely tell you that I see myself at different stages. And I know that there's a long way further to me. But let's move into the Lego side of the story. We started saying because of the technology adoption, particularly artificial intelligence, that the governance, the legal side of the society starting claiming, hey, there may be a danger. We do not understand what is going on. Well, maybe even more, let's say how we tax the newcomers, how we may create new jobs, how we can educate people, how we can educate people actually in a way that doesn't cross the academic misconduct borders and so on. So many challenging are coming. So we need, again, definitions. These definitions are coming from the reference I mentioned, Organization for Economic collaboration, and the European Commission. And of course, you will see actually the data science and AI glossary from the Alan Turing Institute that is practically advising through the scientists, the British government, and indeed other governments, the Canadian, United States government, Chinese government, even actually some other governments. For example, the Indian government is moving very fast. Just to mention, the Saudi government actually was the first one to have a minister of artificial intelligence many years before actually the others started thinking about the goods and the bads of artificial intelligence, needed definitions. And I'm just putting in there on the slide for you just simply to read it, to understand that we need to see artificial intelligence as a digital technology, is a system. And that system has, of course, a software part, which is the, say, mechanics and robotics of processing the data, which comes from the European Union AI Act with something that is called risk. So health and safety is part of the game and the equation of the AI acts, and we need to understand them. And thanks to them, we have definitions of the foundation models, which is the machine learning models trained on vast amounts of data. Nowadays, we're talking about billions to hundreds of billions of variables included into the training, and the production of the different interfaces from, say, the language models to the video models and so on. But remember, these are related to human senses. So let's move on. Where are the technology side, the engineering side of the story is still defined. Generative adversarial networks are the ones that will be involved in creativity, but actually in a challenging way that can be dangerous as well. Because the generative adversarial networks are coming with the competing elements of a generator and a discriminator of producing, oops, fake data. But fake data is a challenge in itself. It's produced for the goods, but actually it's producing the bads as well, because while actually challenging the models to see if they become robust and reliable on their journey as a technology, actually we can produce fakes, and we know about the deep fakes with very much challenging actually of our existence. And of course, the technology creates the generative AI, which is the AI system that is able to generate text based on existing data and information, and to some extent knowledge graphs in terms of the representation, by using machine learning techniques to produce new data. Well, that's already creativity. So part of them, for example, through LLMs, we have the chatbots that are able to talk and even to pass the Turing tests. But I want to specifically actually draw your attention to the top paragraph, the general artificial intelligence, because this is the one of the claims when we have to understand the fake news from the people themselves, because the general artificial general intelligence, that started to be called the singularity. We're kind of touching almost a religious challenge here. The singularity says that there will be a theoretical form of artificial intelligence that would be able actually to solve any task, cognitive task of a human approaches, and become independent in there. and to some extent definitely will pass different, say, Turing tests of different levels, like the total Turing test. We know that actually we have papers about how tests are already passed through different levels, even examinations, different GPTs, Geminis, Copilots, and so on, being able to pass exams for admission in universities, or different exams even actually for professional accreditation and so on. But these are still weak AIs, narrow AIs, because they are able actually to train on specific tasks. They are not creative in the strong, larger sense of the theoretical form of artificial intelligence. More actually into the philosophical side in there, but let's move into, I would call it a confusion matrix that is coming again by visionaries Russell and Norvig in their very much used book for everybody who's done computer science since 1980s and onwards, the AI, a modern approach. Look at the confusion matrix, look at the table. We have the what will be the true positives and the true negatives, the false positives and the false negatives, defined this time by human approaches and systems approaches. So if we have systems that think like humans, which is part of one of the generations of the AI, then actually we have a human based with reasoning ways, which triggers actually the way of understanding what we're doing through systems that can act rationally, but in a way that is based on behavior the humans won't have it. So that will be into the false negatives ways that the AI is stepping in. So if that is the case and the technology is there and we enjoy it, how can we move from the technology side into the humanistic side? Because it seems that we are challenged in our position. This time, the Industrial Revolution is not addressing the basic of the pyramid of needs, but the top. It seems that actually the technology is jumping steps, is jumping boundaries, and we need now to keep the speed with our own creation. So, can we do that? How can we involve the ethical principles that come from the humanistic side, from the philosophical side, and impose it into the technology? The five ethical principles, and there is still confusion, vagueness. The keywords start to be qualitative. We do not know how to measure them. And even actually, they are used interchangeably as well. We have transparency, impartiality, again with justice, fairness, non-maleficence. We have the reliability and robustness, each with its own definitions, differences, and similarities. We have the accountability and responsibility. We have the privacy need and governance and so on, all coming into a list of five. So we need to think where the human and the rational positions are embedded now into the social, into the society, into the economy side, and how we can make this measurable, mm, taxable, at least understandable. So the AI Act introduced this logic of risk. So the systems, the AI systems, must be identified by the risk. And look how this is defined by, again, a pyramid of needs, from the minimal risk, which is the base, the one we can control, data information, the systems based on logic that we can understand, to the top when the risks are high or unacceptable, because either we do not understand, we do not see the ethical side, or challenges and dilemmas are produced. So at least one may like to see transparency, thinking that if I see the system that is transparent, then hopefully this may work. Still, the law allows in the annexes 1 and 2 to introduce updates, because the technology is moving so fast. So let's try now to discuss about these keywords that are coming from the five ethical principles. What is responsibility in general terms? Responsibility will refer to that duty or obligation of the individual or group to fulfill certain roles, tasks, duties in a reliable and accountable manner, because we work together in a society. We are members of the society, so we need to show ethical and moral behavior with accountability, reliability, ethical decision making, and demonstration of intelligence by learning from mistakes being part of the game. Learning from mistakes drives us already into learning that technology must have loops. We need to see how we improve by the performance. One of them being ethics, another one reliability, another one accountability. Part of this kind of a digital technology improvements in order to build trust, respect. Where is the respect to the AI? Actually, we'll see it in a second. Integrity and dignity in individuals and so on. So last year, I introduced this slide, and you can see actually how, if you were last year here, you voted. You can see how many words, and there the list is definitely not closed. There are more coming into the ethical side of artificial intelligence. But I will focus on responsibility and, if we have time, on sustainability, with the other ones being related to it. My exercise for today was actually to see which ones belong to where, but I don't have time anymore. So let's have a look at the industry. IBM introduced their own definitions and their own what is called responsible AI pillars by practically linking to the ethical principles, claiming explainability. And explainability in itself wants traceability, transparency as being there, but performance as well is about prediction accuracy, is about optimization from the industrial perspective. And then is fairness. And fairness is a statistical approach, can be measured statistically. I can mention my colleagues, my PhD students working in this domain with ways to calculate bias, diversity, representation of the data, diversity. But of course, the ethical AI review boards are still claiming the human presence in there. And then is robustness. Robustness is practically a way to demonstrate. One example is exactly that adversarial thinking that our system, once trained, is able to produce, where and how the outputs will be still applicable with trust. But that's the question, because we are losing the access to the data. So we don't know where the data is coming from. If I don't know the ingredients for my food, shall I trust it that is robust and will give me exactly the same number of calories I know from the past? Big question. And of course, transparency and privacy will be part of the game of understanding the responsible AI system and to protect the privacy because of the data. Of course, you can see already differences with other approaches in which the words are used interchangeably. But as I mentioned, some of them can be measured statistically, like causal responsibility automatically can help into the fairness and bias measurements, whereas the moral responsibility will be, say, the ethical side, and the legal responsibility is where our, say, governments are trying to add more. But hopefully we can add our own value into the role and view to responsibilities. So responsibility includes explainability, we said. Altogether, explainability and responsibility will add together value to ethical AI. So the four principles of explainability, according to the National Institute of Standards and Technology and from the US Department of Commerce, include explanation in human terms. And this already is biased. I'll explain in a second why. Meaningfulness, again, in human terms. We need to make it available to people. It's like scientists writing a research project and still we are requested to produce the abstract for a larger audience. So to practically use words that everybody can read and understand, hopefully the message within the same pathway. And then it's about accuracy of the explanation and the knowledge limits. Knowledge starts making its own in here. So I'll tell you where the explanation starts to be biased. So we, within the education, the current education, we still pay attention to the Western philosophy that I said has Greek roots. And this is where our say operators, our operands, and our ways to mention statements with, say, using the and the or and the not will make sense for us. But this is simply because we were trained to think in that way. But there are the cultures still that use different words. Don't forget that even the computers actually, the integrates, the chips use XOR and XAND, not and or. So actually, they make additional calculations for us, for humans, to understand the logic in the hardware. And this says that practically technology has a way to play translations to our logic, the one that we are learned. Hopefully, maybe other people have, and we know it already in other philosophies. Asian philosophy is actually coming from the Oriental way of thinking, from the South, a global South. They have another way to express themselves. Sometimes that will provide us more sustainability in how explainable intelligence works. And this is again thanks to my students work in this area. I started understanding more how we can check this for a better reasoning interpretability. So part of the explainability, we have the interpretability side, which is how the humans will interpret what the systems are doing. And this will come with their own challenges, because this is where we have problems with adoption of artificial intelligence in real world applications. The interpretable models that will allow, for example, the legal teams to make somebody accountable or not will need an explanation, will need an algorithm deciphering, and will need the interpretation to be really relative to the function of the system in order to raise its trustworthy approach. So where is the explanation linked to the human understanding? Well, again, we have to link it to philosophy, because we have the ante hoc explainability, which means interpretability and transparency are by design, are implemented into the hardware. We know this happened in the first ages of artificial intelligence during expert systems, knowledge-based systems were taking rules either explained by an expert or calculated statistically, for example, in Bayesian network, and then we implemented them into the systems. There was a lot of effort because we needed to create the data and information, but the systems were interpretable. Nowadays, we do not create the data with the meaning to have interpretability by design. We simply make use of existing data. So the noise in there, while being creative, is not explainable anymore. We cannot actually create explainability methods because the way a neural network learns is not the way we can explain it well. And this is how explainable AI and responsible AI start having boundaries, start having different approaches where explainable models like decision trees, Bayesian network, and to some extent they're complicated random forest approaches that can be still translated with a little bit of effort, plus rule-based systems, plus the logistic expressions and so on, will allow us to understand using our own vocabulary how the system works. But when we move into, say, the post hoc explainability that we want to happen after we train the models, the effort is big. Even for myself, sometimes when I'm reading the code I created 20 years ago, it's difficult, but forget about when we do not know where the information is coming from. So, where the explainability in the opaque AI will do is, well, I have a system that produces outputs with good performance, good accuracy, but can I trust them? Well, how can I define trustworthy AI then? We have a journey of the ecosystem from training the AI on data because we are happy to have data. Where is the data coming from and so on? And then we deploy a system that we say is 90 something percent accuracy, 99.99%. We store it in a cloud platform and we reuse it, but how much can we trust it? Where is it coming from? How has been trained? Where is the human agency in there? Should we put a human actually officer to test it, and how? And then, but we have so many variables in this equation, isn't it? So we have the convenience, the quality, the privacy, the data governance, the transparency, interpretability, and we have the fairness. And so, oh, that's too much. How can we make accountable? Who's accountable of the mistake done by a system once in a while? Well, as we mentioned, transparency must be linked to knowledge. So if we do transparency by an epistemic maneuver, practically by design, okay, not into the rules at the start, but within the process, if we're at least able to understand how data sampling, how the model, the learning ability of the machine, and then the model itself is not just created but at the same time validated, maybe we have a journey. And I strongly encourage you to read this paper, because it's extremely challenging. Is a paper that I'll mention again Justina here. Thanks to her studies in philosophy, I learned about it from our colleagues from the University of Bucharest in Romania, from the philosophy school. They said we have black box algorithms creating beautiful models to identify cancer from MRIs scans. Okay, so we identify cancer better than a human expert. Of course, there are other papers saying human experts plus AI technologies, deep learning technologies identifying cancer will work even better. Brilliant. So can we adopt them in NHS, for example? We do trust them. So you see just a machine taking the scan, another machine will do the interpretation of the scan, and then there will be no expert. There will be a kind of a GPT-like, so an LLM talking to us and saying, "Don't worry, enjoy life and the Yorkshire weather because you do not have cancer." Shall we trust it or not? Well, these authors say we can put performance of the output in a way into the methodology to say that actually we can still adopt this technology even if we do not understand it in a human way. But this is actually an approach that happens in the theory of virtue and later on in utilitarianism, in which if we create pleasure, say profit or happiness, a happy output, or at least an exact output, then we're happy with the system even if we do not understand it. But this is a dilemma, isn't it? Still, it happens. I'll show you examples in a little bit. So while we still have opacity, if we can demonstrate that opacity produces good results, we should still adopt it. That's a philosophical, ethical dilemma. I'll leave it with you to think in the Friday night. Okay, but interpretability of the machine learning will give us models about that. And this is the journey I mentioned about the paper. Please have a look at it, read it, and take their points. See if you can adopt it in your own technology. But the question is, so for example, for radiologists, people actually taking the scans and interpreting them, what are you doing? Am I losing my job tomorrow? Am I like a taxi driver because there will be automated cars driving and so on? So am I on what I'm doing? Shall I actually study computer science and AI at the University of Bradford tomorrow because I don't have a job anymore? No, the answer is, and I've taken the answer actually from the authors in a second. In one of the previous slides, they are saying radiologists without AI training and AI tool usage skills may lose their jobs because the jobs will be enriched by the technology as part of the industrial revolution. So radiologists with AI training for scan interpretation will keep their jobs. See where I'm going to? The fairness through awareness within the principles of applications and adoption of technologies. Very quickly, fairness in itself is a big challenge. We know how many dilemmas where practically from partial impartial journalism to data used in different hospitals trained on particular populations, missing minorities, missing gender, missing age, and automatically creating discrimination and automatically creating unfair algorithms and models by the different types of bias, like biases from the data, biases from the algorithm, biases from the user itself when they interpret the data in the processing part, unfair algorithms from explainable discrimination, unexplainable discrimination. We say, see the output we don't know where it's coming from, and the sources of discrimination, how we can actually see diabetes linked or not with obese people or some minorities or some genders in particular areas or some income in the families. And then we have to think about the fairness by design. So as I mentioned, there are 3 steps of bias measurement. The bias by, so practically by fairness, the bias by discrimination and the bias by or fairness by design. So to be able to design systems that are not biased, practically they are not unfair. And now I'm coming closer and closer actually to the last bit. Sorry for it taking a bit longer. I'm still happy. I'm not very far away from the end. Remember the word singularity because that's the journey in here. So information from description and diagnostic sides, which practically play games with explainable AI as well, with systems that we can read, with a priori knowledge, okay, are moving into the prediction and prescription. This is where we start seeing what? On one side, prediction is the hope. We want to be told in the manufacturing sector when a particular product can be faulty, where is the weather going tomorrow, when or not we'll have a strong rain, flooding, or I don't know, very hot weather, when or how we can avoid an accident into traffic, how we can avoid spending time doing work that is not practically at our level of understanding. So how we can do prediction, how we can do prescriptive analytics then with AI, because we want that, but we're afraid of that. So how we can move from a priori knowledge to a posteriori knowledge, building not just from data and information, but knowledge as well to create, do you remember the keyword? In DIKW, wisdom. Well, we start moving into the area of philosophy where generative AI is playing the games because generative AI starts to be how? Well, actually, generative AI is creating fakes. Generative AI is faking. Do you remember the most used word with generative AI that is challenging us? It's called hallucinations. But hallucinations have an interesting effect. They are creative as well. Well, sometimes they are making us laughing, sometimes they are making us surprised, but sometimes we are making us saying, wow, this is better than I thought. For example, in prompt engineering, to create a summary of a particular text or a particular reading, isn't it? So my point was to bring together the pyramids we had in the first slides, the pyramids of risk in which we are told by the regulators, take care, artificial general intelligence will take our society, our environment, our lives, our power, our everything, ourselves. On the other side is our dual approach of machine human ways in which wisdom actually involves what Kant said, thanks to Justina, I'm saying this, conscious responsibility by consciousness. So actually, the question for the people who are talking about singularity is, can the machine reach consciousness? Look at the table generated by Gartner with the bottom things with high value, high quality, high trust, high expectations, functionalities from AI, to the ones moving into the knowledge where we are in the amber area and the low quality things. Well, I'm not saying they will not be solved and resolved, but the machine is still far away from wisdom, but it shows signs of wisdom from a human interpretation viewpoint. So this is actually the current approaches. So I'll run now from the examples to come close to the real world and to enjoy the Friday evening. So my points in here will be simply to tell you that the challenge and the people who will talk about artificial intelligence more than a digital technology, a digital information knowledge technology on the on the engineering side, will play games with us. I'm surprised that even MIT Technology Review is personalizing the artificial intelligence. But when we see um, titles like Explainable AI identifies, even innovates a new class of antibiotics, I'm asking myself, was there no human being in there, at least to design the way to draw through the data, to scrub the data, to put the things together. No human creativity anymore. But actually, if you go to that website, you will see that the explainable AI in the title inside is somewhere actually coming. Inside it says the scientist, hopefully actually is coming, yes, it's here. The scientist, so see the title is here, but inside is about scientists discovered the class of antibiotics. Okay, so it's not the AI. The AI doesn't have personality, doesn't have ID, doesn't have a passport, though we're coming back to this. And I won't go there, I'll just name now the challenges. Look, mental health now support is already given to sections of patients in NHS by limbic kind of bots. And there are technologies, for example, Future You. I'll just encourage you to read it, in which we face ourselves in the future. I don't recognize my face now. I don't recognize it in the past. I don't recognize it in the future. I don't understand how to react to myself when I'm looking in the mirror. So I'm kind of neutral with this, but talking to ourselves. So actually creating deep fakes of ourselves in the future, well, that's is a dilemma for me. Deepfakes for grief bots. So practically inventing, creating deepfakes of our people. I'm not talking about the presidents of the United States now. I'm talking about our family, actually to talk to us in order to, I don't know, affect the grieving story. Oh, wow, that's a problem, isn't it? Read about them to see more. But remember that deepfakes were created with data, and some data can be like the 80 million tiny images data set that included about 2,000 out of the 80 million images scrapped from internet and labeled automatically with racist, offensive, discriminatory, even child sexual exploitation content. Wow. Since then, this data has been removed, but some machine learning models trained on that data still exist. That's a challenge, isn't it? So when we're moving, I'm trying to move faster now because I know we're late, through the industry opportunities in real world. Just read the book there. There are 100 opportunities for business ideas where APIs into this generative AI will create better or worse business models. And some of them are really, really great, editing the CV, practically creating a summary for us, but some are, I don't know, a little bit more into the challenging area. Unfortunately, I'll leave the sustainability task for maybe next year talk, so as that we can come back to this, because the AI is coming with a lot of energy consumption and a lot of environmental factors, and at the same time, the models must be sustainable themselves. And we can ask ourselves to reflect how we can align the AI technologies we are part of with the United Nations 17 Sustainable Development Goals. And I have colleagues here who can give us even better understanding. But remember, a sustainable AI has both roles: to be sustainable themselves and to produce sustainable outcomes. So more to read. Beautiful work done by the authors into these papers. I just put the slides in here to demonstrate the positive and negative impacts of artificial intelligence on different SDGs. And I'll move straight to the end here because I wanted to show you something to reflect. So we are now into the last slides because I want to run this video, which I understand you may not necessarily hear it. It doesn't matter. You can search for it. This is the BBC Boston Robot Fights Against Pushing. I want you to watch it, and it's just 1 minute and a bit because I want to ask you something. So I don't know if you can hear me, but look at it. So my point is, what do you feel when you watch it? What do you feel? That was reinforcement learning for the robot and was supervised training, supervised testing strategy. So nothing new. How do you feel? Just because the robot actually has humanoid kind of shape and behavior, I think our humanistic side starting reacting, isn't it? We felt sorry for the robot. Sometimes we felt the aggressivity in the human interaction with the robot. And we felt a little bit like, what next? Where is the accountability? Where is the responsibility, isn't it? So I think if we want to reach an ethical age of artificial intelligence, we need firstly to produce evidence with ourselves on ability to learn, apply knowledge with ethical, transparent, impartial, reliable, robust, accountable, trustworthy, responsible, wise, and conscientious manners. That was my talk for today. I acknowledge the work of all my colleagues, all my undergraduates and postgraduate students, all my researchers I am in touch with, and I practically benefit of their work, known or unknown. So thank you very much for your patience. Happy to take some questions now. Thank you. Okay.
Thank you for that, Dan. We have got a question in the chat if you're okay to answer.
Yep. I'm trying to look at it. Shall I keep sharing the screen?
Well, at the moment, we can just see you, so you're not actually sharing properly at the moment. But
I know that is this
so
kind of a voice story, so I want to avoid it. Okay. So let's have a look at the questions.
Given that a GPT query uses up to 25 times more energy than a Google search query, what strategies are being explored to optimize the energy efficiency of AI models? How can regulatory bodies and the AI community collaborate to promote more energy efficient AI technologies? And how can the AI community drive innovation in sustainability practices to reduce the overall environmental impact of AI technologies?
Hi, Jacob. Thank you for the question. It's exactly the part that I missed it because in those slides, we're talking about how AI is addressing the sustainability goals, one of them being related to the impact to the environment as well as the impact to the human beings. And it's still a big challenge. You remember that the data farms, the server farms are moving anywhere from in vicinity of dams to the poles, closer to the poles, in order to benefit of the cooling, say natural cooling, into the waters as well. So big challenges. And I think the answer is in how the technology will improve itself, both in terms of the computers. Nowadays, for example, you can see the circuits, the computational part being optimized for artificial intelligence processing. So practically neural networks to be trained directly through the integrates. We can have actually the microchips designed for the different ways of learning. So this is coming, technology is moving. So it's very exciting news for us. But at the same time, the way the power is managed, the way the say the cooling effects will be managed, the way the communication itself is managed are challenging in themselves. So sustainability with governance should play the game. some technologies more will add even more, say, consumption in terms of the energy. I'm looking at blockchain technologies, or say technologies that will produce federated learning, in which we use distributed way of processing. So more challenges to come for computer scientists, for say people working into the electrical and electronic areas in energy management. There is no one solution at this moment, and I think the things will become in the future even more challenging, because the way forward is to include what is called passports. So practically, there will be passports as they are now for, say, recycling things in a circular economy. I just read about passports added to particular products already in the manufacturing area. You see passports associated with models, and this will come even with, say, challenges related to how they were created, how much energy they produced for training and retraining and so on. So no, I don't have an answer. I have more challenges, I would say, but that's a job for you, Jacob. I'll look at you and your colleagues to produce the solutions of the future, because you are in the position to come with the solutions. I'll come with the questions to test the performance of the solutions you can create. That is a good, actually, project in itself. Thank you.
We have another question from Chris Skinner. So, thinking about wisdom, are we likely to move towards a reality when people carry in their own personal philosophers, notifying us when we faced our decisions, outsourcing our ethical or logistical or whatever value structure orientation implications?
I would cite here some of my PhD students who share not just um, say more than one language speaking, which is in itself a talent, but actually more than a philosophy exposure. For example, Meenakshi is working into applying Indian philosophy, Nyaya philosophy approaches into the current artificial intelligence responsible measurement and validation. And the fact that people have, say, show diversity in the way logics, ethics are named and work is actually good news. We learned, if you look into the, say, genetics, we learned and we created the opportunities because we are diverse. And I think this is an opportunity for artificial intelligence in itself to not be tributary just to, say, Western philosophy, but actually to any philosophy. We may see in the future, actually, approaches of, say, multivariable, multi-operator, multi-operand philosophies and logics that may create opportunities for us to understand AI in the way today we cannot. So, wisdom is, in my opinion, the approach to gather diversity and, say, multi-valued logics. If I'm a bit limited here because I didn't want to say it's Lukasiewicz logic, but different types of logics into the way we implement artificial intelligence. As it happens, because of the knowledge graphs and because of the ways the information we don't know where it's coming from is processed, at least maybe other philosophies and other logics may help us in there. Many thanks. Very, very good question. I should to take it forward. I need to take a snapshot of that question. Thank
Two,
you, Chris.
so Chris has just actually said he didn't word it very well, so he's going to ask. Okay, so if you give me a second, I will just unmute you, Chris,
Yeah.
and find you.
Thank you so much. I was madly typing and yeah, but a very interesting answer there as well. And thank you so much for the lecture, so much to think about. What I kind of came away with there is that is there a possibility that, and I think we might already be having that with Chat GPT, where people are just is running. And so what I'm thinking is there models where I have it running all the time and it's observing me and my surroundings and telling me what to do. And then I essentially outsource my decision making to the model I like. So am I, am I, let's say, spiritually oriented, or am I financially oriented, or am I power oriented? or what are the models that I want to pursue, and then do I have nudges all the time? Is that something you see on the cards?
Well, this is where, so I didn't want to mention it. I will still record it. Yes, we are probably. So if you remember the deep fakes that are used with business models, like,
Mm,
so I'm not talking about the ones used like attacks against persons, as it happens actually, but the ones that are used like a
mm,
business model. I spoke about the grief bots and the ones for healthcare, like patients like me. So talking to somebody to identify more things. There is a big chance in there to have subliminal information, both captured
mm,
and sold out. So part of the information and knowledge that were exposed, because the current LLMs are nothing else but the exposure of the data they were trained with, which are, if you wanted, as we belong to cultures, even for example the generation, isn't it,
mm,
born in the 2000 to 2010, 1900s, 1960s, 50s, and so on, these LLMs become generational. They belong to a particular collection of information that was used for their exposure. And the way it works, I've done it with myself actually. For
mm.
example, originally having a book created on my name by chatting with ChatGPT and saying, "Oh, you've done that book." It was not true, but then I said, "Yes, but I want you to know that this book is mine." And finally, he started promoting it to others as well. So it's a kind of a two-way approach, or actually multi-way approach, into promoting information and knowledge from different sides. And we'll see it in the future. And this is where prompt engineering is coming. You mentioned it very correctly. So we start learning how to use this technology to interact with us in order to optimize some of our expectations. And this is why I wanted to have
Mm.
the last slides about the humanistic side of the story, because definitely some people will use it for, say, negative values, for things that can be dangerous, non-ethical, imperfect, and so on. Is a way to learn in the
Mm.
future. It's just another digital technology. At the end of the day, cars are used to kill birds, cats, dogs, vegetation. We cut blossoming things that actually will not be there tomorrow. We cut trees and so on. So with tools that are part of the previous industrial revolutions, it's the same logic. We started already to be used with artificial intelligence as a technology, but it has this humanistic touch more. Of course, we can have reactions to a chair or a wall or a building or a memory, a picture, isn't it? And this will train ourselves how to use in the future the technology with, hopefully, a positive side. There is no way to control it. The single way to control it is by the power of example. We need to become specialists in using these technologies with evidence, and even to participate in their training, such as to avoid the negative side, to avoid the explosion, the gas explosion, the electrical power cut, but at the next level, knowledge level, and hopefully wisdom level. See where my point is? Yourself and ourselves are part of the equation.
It's dynamic.
Hopefully it is dynamic and is a
No,
learning
but yeah,
curve
yeah,
as well.
it's back and forth.
Yes,
Yeah, no,
exactly.
really interesting. Thank you so much.
Thank you very much, Chris. And thank you for actually giving feedback, because talking, I remembered actually the COVID time. So talking in front of the camera without knowing and seeing people is a bit of a challenge. So thank you very much. The feedback was great. Um, yes. I see John's question, as well as logic, philosophy, ethics, and wisdom. Will AI have emotions and motivations? That's the consciousness part. So emotions for the AI. Remember the the movie from Boston Dynamics showed the robot, the Atlas robot, at some point a little bit like reflecting if it will go further away, so forward or backwards, isn't it? So this is our interpretation of it's simply our interpretation of the reactions. Yes, the answer is we can implement algorithms that for humans can be interpreted like emotions. we have actually robots. There are even in the slides. There is if you join in LinkedIn the generative AI network, you'll see a robot. I think Alma is called, that has this kind of a first experience of seeing itself in the mirror and showing emotions, but the emotions are algorithmic technically. So emotion like surprise, sadness are implemented for our eyes, not for the artificial intelligence. So the consciousness part is still to come as a way to implement it. My point was actually a little bit different. So because we felt sorrow, we felt sorry for the robot, and we felt the aggressivity in the reaction, we need to start learning to be ourselves correct in order to have the interaction correct as well. And I was thinking about being algorithmically correct as well. So practically to have ethics by design in the robot creation. Yes. So I don't know how if I answered John's question, but emotions and motivations. Motivation is there again like a mimic in the dialogue. Emotion is a way to go. One of the things that I included with my colleague Dr. Paul Trundle in the past in our research was to look into empathy, which is an emotion in itself. And this is the way to say create ways to identify computational measurements for qualitative variables. Not easy to manage, and they depend from culture to culture. Yeah, so it's a journey. Yeah, the emotions not yet, but there are games that are coming into the market. Xavier says that I did stress how ethics is a key question for AI. How do you see this topic reaching some of compromise? Yes, that's the point. Well, culturally biased, no chance. Depends on the data. And what is the big difference into the generative AI compared with the previous versions of artificial intelligence, like rule-based systems, is the fact that we do not have control anymore on data. So we do not know what is going on in there. Practically, the AI models are not deterministic anymore. So measuring them and being culturally biased, no. My answer for you is the passport. So saying that this AI model is trained on this data, so represents this, will say I may be biased because of my training. I'm not saying that I don't want to be diverse. I'm saying that I am at the moment trained to do this work. And then I want to be acknowledged as that. For example, look at my glasses. I am biased because I need the glasses to read your name, correct? So I need a particular technology to adapt myself to read your name. It's the same with the technology. For example, we have work still ongoing on, say, diabetes data that doesn't represent a particular minority in which diabetes is highly representative, is there, but the data is small, and automatically that model is biased against that minority. But if I will say explicitly that my model is based on data collected about that population, if I do not see myself in, I said, I don't need that model. I need one that is, say, representative for me. It's like practically making use of a bicycle or not at a particular age, or a car or not. I mean, do I drive vans? I am allowed to drive vans, but I don't consider that they are useful for me, and I don't feel very safe sometimes in driving vans, so I prefer not to. So we have to decide which technology we use. Somehow your question is very much related to Chris' question, which I appreciated. Okay, so John comes back with, but without those, could AI ever be considered intelligent? That's my point. So is the word intelligence what one? Maybe AI can be considered intelligent, but maybe it cannot be considered wise or empathic. So this is where the level depends on the generations of the things. So remember that we have now this kind of a hybrid set intelligence in which chips are integrated into say biological nerves. Another way to go forward by supporting people or supporting the machines. I don't know which side we want to measure. So technology is there to continue challenging us, and we're part again of the equation. So without those, AI could be considered intelligent depending on the definition. And this is why my talk today was about concepts and definitions. I wanted to have together ways to discuss about that. I think we're going to finishing closely because actually we don't have much time. But okay, so Jacob came with another. Thank you, John, with another question about ethical considerations and risk. Exactly. Yes, so that's the point. This is why the European Commission, this is why many scientists and many business people introduced risk to AI. It's part of the passport. I'll consider it a variable. And yes, it's the point of how much we trust or not what is used for. As any technology, at the end of the day, the technology of firing a cigarette close to a gas pipe is dangerous as well. So we are part of the equation, and I want you, Jacob, to look at the question and help us to move into the AI technologies of the future. Looking forward actually for a good project, isn't it? Thank you. Thank you, everybody. I think I've addressed the questions, and I want to thank you, everybody, and to tell you that I'm open to leave the slides in a PDF format with all web links working for our BCS West Yorkshire people to publish it, so you can see it together with the recording later on. And I'm happy to take the questions further. Many thanks indeed. I'm so happy that I had you spending your Friday evening with me here. Now we can go, everybody, to enjoy a bit of a happy and humanistic Friday evening. Thank you very much.
So massive thank you, Daniel, and thank you to all the participants as well. I hope it was informative. And hopefully you'll come back and do another talk in future.
And I have some very good colleagues and some very good actually students as well who would like to. So I'll extend the invitation to them if you don't mind. Can I?
Yeah, of course you can. We're always open to have talkers. So
thank you. I'll do so because we have so many talents around us. I don't think I should be just a unique voice. I know I should have people better than me and more talented. I'm playing now the AI side of the story. So I'll become an AI
take all the
nerd.
credit.
Yes. Indeed. Many thanks indeed, Chris and Dan, for the invitation. Many thanks, everybody, for spending time with us, and have a good evening and enjoy the AI usage together with the humanity side. All the best.
Thank you very much.